Hey guys, welcome to our Properties of Exponents notes video. I'm going to swing through these as quickly as I can so as to not take a bunch of your time. However, please remember you are always welcome to pause the video to catch up on notes. The first property we're going to talk about, and there are quite a few today, is the product of powers property. So this property says that you can multiply powers that have the same base. That's going to be our important thing for today, is that everything has to have the same base by adding the exponents. So once we have the same base, we are just going to add those two exponents. So for instance, I have 2 to the second times 2 to the fourth. So we're going to go like this. We're going to add those two exponents, 2 to the second plus 4, which would give me a final answer of 2 to the sixth. Now we could have written it out like we did yesterday, and we could have written out 2 2s. We could have written out 4 2s, added them up, and got 2 to the sixth. Now we can simplify. We can do the algebraic example, which means we're going to use letters this time. So maybe we're going to use a to the fifth times a to the 11th. I don't know about you, but that sounds like a lot of a's to have to write out. So I would much rather just write a to the 5 plus 11, which simplifies to a to the 16th power. The next property we're going to talk about is the quotient of powers property. So that means we can divide powers that have the same base. When we multiplied, we added the exponents. So now we're going to subtract the exponents. All right, so for instance, we could do 3 to the second power. Actually, let's do a bigger power. Let's do 3 to the fourth power over 3 to the second power. So you could write it out and write 4 threes and then 2 3s and cancel out them, all of that sort of stuff. Or we can simplify it to 3 to the fourth minus the second, which would simplify to 3 to the second power. Our algebraic example, we could use b's this time. We'll use b to the 10th over b to the 8th. And rather than writing out all those a's and having to cancel out all those a's like we did yesterday, we can do b to the 10th minus the 8th, which gave me b to the second power. Much faster, much easier. Now let's talk about the zero property. The zero property means that all expressions with a power of 0 equal 1. The only exception, of course, being 0 itself. So for instance, if I have 3 to the third power divided by 3 to the third power, we can subtract again, 3 to the third minus 3, which would give me 3 to the 0 power, which anything to the power of 0 is 1. So I would simplify that to 1. Algebraically, we could talk about c to the fifth and c to the fifth. C to the 5 minus 5 is going to give us an answer of c to the 0 power, which would equal 1. No matter what it is, if it's to the 0 power, it's 1. Okay, so now let's go ahead and do our next one. I'm running out of colors already. Our negative exponents. So anytime you have a negative exponent, it can be rewritten as a positive exponent by writing the base as a reciprocal. And changing the exponent to a positive. So let's talk what I mean by that. So for instance, let's do our arithmetic example. If I have 4 to the third power and then 4 to the fifth power, I would say 4 to the third minus the fifth, which gives me 4. 3 take away 5 would be to the negative second power. The way I'm going to rewrite this is I'm going to make the fourth into a reciprocal. I'm going to flip the fraction and make it into 1 over 4. And then I'm going to rewrite the exponent as positive. So it would be 1 over 4 to the second. Now I could go through and I could expand it out and I could say that that's 1 over 16 because 4 to the second power is 16. That would be our standard form. Remember we talked about those different forms yesterday. All of our examples for this week are going to talk about exponents in exponential form. So we would leave it here in exponent form. If I were to ask you to do standard form or simplify it, that's when I would ask for the 1/16. The algebraic example, maybe I have d to the 5th power and d to the 10th power. So I would go and I would simplify d to the 5 minus 10. 5 take away 10 would give me d to the -5th power. And because it's a negative exponent, I flip the fraction, make it 1/d, and then I simplify that to a positive exponent on the bottom. So reciprocal, and then flip the sign of the exponent. Basically, that negative exponent is saying, hey, I'm on the wrong side of the fraction. Put me on the other side of the fraction. All right, so let's talk about a power of a power. So a power of a power can be simplified by multiplying the exponents and keeping the base. So what I mean by that is if I have like 3 to the 2nd power, all raised to the 3rd power. We're going to multiply that 3 to the 2nd. So we're going to multiply just like we did when we multiplied separate powers we added. Now we're going to multiply them. So 3 squared times 3 would give me 3 to the 6th power. Algebraically, we could do like a to the 5th raised to the 4th power would be a to the 5 times 4, or just a to the 20th. That's like writing out a to the 5th, so a 5 times, and writing that 4 times. That's why we get a to the 20th. We multiply that because it's going to get really big really fast. The power of a quotient. So the power of a quotient is the same thing. We're going to multiply the exponents. And then the difference is we're going to simplify the quotient if possible. So over here, let's talk about the arithmetic example. We'll do 3 to the 2nd over 4 to the 5th. And we're going to raise all of that to the 3rd power. So I'm going to multiply that 3 to everything in the parentheses, everything in the parentheses. So I'm going to do 3 to the 2nd would be 3 to the 2nd times 3 over 4 to the 5th raised to the 3rd power. So now I'm going to simplify. 3 to the 2 times 3 would be 3 to the 6th. 5 times 3 would be 4 to the 15th power. This case, we would not simplify because it's asking for us to leave it in exponential form. If I were to ask you in standard form, which I'm not gonna, but if I were to, that's when you would actually take those exponents and simplify the fraction. But that would be a crazy number. That's why we're gonna leave it in exponent form. The algebraic example, maybe I have a to the 5th over a, let's actually change that. Let's do a to the 6th over a to the 2nd, all raised to the 2nd power. So now we're going to go and do a to the 6th times 2, a to the 2 times 2. So I'd get a to the 12th over a to the 4th. In this case, I can simplify because those have the same bases. In the problem before, we had 3 and 4 as our bases. Those were not the same. A's are the same in this case. So we could simplify this by doing a to the 12th minus the 4th, which would give me a to the 8th as my final answer. So keep working it until you can't simplify any further. All right, and our last property, and this one's probably my favorite property because it's the easiest property, it's the identity property. So it states that any term raised to the power of 1 is itself as if multiplied by 1. So if I were to have an answer, and maybe I'm doing 3 to the 3rd divided by 3 to the 2nd. So I get 3 to the 3rd minus 2. 3 minus 2 would be 3 to the 1st. So I could just write it as 3. Algebraically, I was going to do x to the 10th divided by x to the 9th. I would get x to the 10 minus 9, which would be x to the 1st, which would just be 1. Doesn't matter that it had a variable, or excuse me, it should be x. I wrote the wrong thing there. Doesn't matter that it had an exponent, we just write the variable. All right, so let's go ahead and look at the practice. I'm going to zoom in and look at 2 at a time here. So I like to use different colors for these. You guys know me, I like to use a lot of different colors. First things first, I multiply each element by its common element. So I've got a -3 and a +4. Those are my 2 coefficients, my 2 constants. So I would multiply them. -3 times +4, and we get -12 as the first part of my answer. The next thing I've got are my b to the 7th and a b to the 2nd and a b to the 1st. So I'm going to write b to the 7th plus 2, because we're multiplying. Don't forget, this one doesn't say it, but that's a +1. So now I have 7 plus 2 is 9, plus 1 would be b to the 10th. And then I can write my A's. And now you'll notice I left a spot for the A's because we always put our letters in alphabetical order. That's a to the 1st plus a to the 1st, which would give me a squared. So when I read my answer, my final solution would be -12 a squared b to the 10th. That's my final answer. And I'll come in here and I'll box that with my darker pen. All right, so let's look at problem letter B. Again, we start with our constants of 2 and 3. 2 times 3 gives me 6. Now let's go to my x's. I've got x squared, and that's my only x. So I have x squared, no adding, no subtracting. So I write x squared. Now we can talk about our y's, got quite a few of them. Y squared, y to the 4th, y to the -3rd. So we're going to write y to the 2nd plus 4 minus 3, because that's a -3. So 2 plus 4 is 6, minus 3 would give me y to the 3rd. And again, we'll come in with our darker pen and box our solution. Let's go ahead and scoot over to C and D. Remember, if you need to, you're always allowed to pause the video to catch on up. So this particular problem, let's go ahead and first we need to multiply out our exponents here. So I get a to the 3rd, b to the 3rd, a to the 5th, b to the 5th. So now I can start and simplify. I've got an a to the 3rd and an a to the 5th. That's a to the 3rd plus 5, which would give me a to the 8th. I've got a b to the 3rd and a b to the 5th. So b to the 3 plus 5, which would give me b to the 8th. And we could box our final solution. All right, so the next one, we are going to multiply. I've got a -3 and a +4. -3 times +4 gives me -12 again. Let's talk about our x's. I've got an x squared and an x to the 3rd. So I'd write x to the 2 plus 3 because we're multiplying to get x to the 5th. I've got a y squared and a y to the -1st. So I'm going to do y squared minus 1 because we've got that negative exponent. 2 take away 1 is 1, so we just write it as y. You don't ever have to write any exponents to the power of 1 because they are themselves. So my final solution would be -12 x to the 5th y. Let's scroll on over to the other side and let's look at E and F. So for E and F, we need to first distribute the 4 and the 2. So I would get S to the 4th, T to the 4th, S to the 2nd, T to the 2nd. Now I can go ahead and simplify. Let's first talk about our S's. They are on top of each other, which means now I am subtracting because I'm doing a negative. So I'm going to get s to the fourth minus 2. S to the fourth minus 2 would give me s to the positive 2. I'm going to do the same thing with our t's. T to the fourth minus 2 would give me t to the second. And that would be my final solution. Looking at problem letter F, I've got constants of 14 and 2. 14 over 2 would be 14 divided by 2. 14 divided by 2 would be 7. Now I can go in and do my x's. I've got x to the third and x. So I've got x to the third minus 1. Since we don't see an exponent, we know that there's an exponent of 1 to give us x to the second power. I've got a y and a y. Both of those are 1s. So I've got y to the first minus y to the first, which is going to give me an invisible y to the 0 power. I say it's invisible because we don't actually have to write it, because anything to the 0 power is 1. So we don't have to write any of those 1s in there. And then our last thing would be that z to the fifth and z to the first. So z to the fifth minus the first, which would give me z to the fourth. So my final solution, when I rewrite it, would be 7x squared z to the fourth. We would not write that y in the problem. Let's look at G and H. Again, I'm always going to start with my constants in the front, my coefficients. Whoops. I've got a 5 and a 20. 5 over 20. So I'm going to write it off to the side here. 5 over 20, when I simplify, is going to give me 1/4. 1/4. So now I've got my A's. I've got an A to the third and an A. So I've got A to the third minus 1. A to the third minus 1 would be A to the second. My last problem is going to give me B to the second and B to the fourth. So I get B to the second minus 4, which gives me a solution of B to the negative second. Now that I have those three parts, now I need to put it all together in a fraction bar. I write 1 over 4, 1 over 4. A squared goes on top because it is a positive exponent. B squared, so B is going to go on the bottom of the fraction, and that 2 is going to become positive since we moved it to the other side. We're going to erase the 1 because we never have to write that 1, because 1 times A squared is just A squared. So my final solution would be A squared over 4B squared. Our last one, we're going to look at our coefficients first. 10 over 4. 10 over 4 is going to simplify to 5 over 2. Now let's talk about our s's. I've got an s and an s to the third. So I've got s to the first minus the third, which gives me s to the negative second. Remember what those negatives mean. And then we're going to do t to the fourth and t. So t to the fourth minus 1, because there's no exponent, we assume it's a 1. And I get t to the third. When we write out our final solution, we write 5 over 2. I do have to write both of those numbers because I can't simplify that. There's no 1 to eliminate. S to the negative second goes on the bottom with a positive exponent. T to the third stays on top since it's positive. So my answer would be read as 5t to the third all over 2s to the second. If you guys have any questions, Mrs. Vaughn is on Zoom office hours today from 1 until 2, or you can reach out by email. Don't forget, we're going to be talking about these more over the coming days, but I did want to show you some examples today. If you've got questions, please feel free to reach out. Otherwise, have a great day.